Hi and welcome to this fifth video on a GUI based approach to machine learning and sports betting. Okay, in this video I'm going to take a look at hyperparameter tuning. Let's get started. I've loaded up a data file of horse racing for 2011 to 2013. Now the first thing I'm going to do is clear all the input variables or the input features, and I'm just going to create a model on a simple subset of the input features, month and days since the horse last ran. Now I'm going to look at hyperparameter tuning from the point of view of k-nearest neighbor machine learning algorithm. So I'm going to go up to the model here and select KNN. Now I'm going to click on create model, and we get the sub window up, and I'm going to talk about these two hyperparameters down here, which we can fiddle around with and see what the effects are on the model's performance. First of all, let me explain a little bit about how k-nearest neighbors works. What it does is effectively try to predict the win-lose outcome of data based on these two input variables, month and day since last run. So it's going to try and predict a 1 or a 0 depending on whether it thinks a horse can win, and it's going to do that with a probability measure. But in order to do that, what it will do is it will look at the whole data and try and find the closest match it can find from the previous lines of data that matches in terms of month and days LTO, days since last run. Hopefully it can find some lines of data where the month is exactly the same as the line it's trying to predict, and hopefully where the days since the horse last ran is exactly the same as the line it's trying to predict. But if it can't, it'll find the closest it can in terms of month and days. What it's then going to do is take a number of those closest lines and effectively look at their outcomes, which is of course the FinPOS, and it's going to take a voting mechanism on it and see how many were winners, how many were losers, and produce a probability based on that. Now this brings us to the first hyperparameter. This is the actual number of neighbors it's going to examine, nearest neighbors. It's going to go and looking for 7 of the closest neighbors it can find and base the prediction on that. So we could change that. We could change it to 9, 11, 13 and so on. The second hyperparameter is the distance metric. This is actually the way the algorithm will calculate how close a line of data, that is to say month and days since last run, is close to the data it's trying to predict. Usually the Euclidean algorithm will just take the closest sort of straight line distance between the two sets of features that it's comparing. You can think of that as a kind of train journey from Birmingham to London being, as the crow flies, a straight line. But as we know, I'm using an analogy here, but journeys from Birmingham to London can be measured in different ways. You could measure it via a train journey, which would be a different distance, or a car journey, which again would be a distant distance because of the path. So this is a straight line measurement that it's going to use to evaluate the distance between these two variables in the line-by-line data it's going to examine with the line it's trying to predict. We've got other algorithms here which I'm not going to go into in detail, but we've got four available here that we can choose from. Okay, we're going to run this with tenfold cross-validation. We've mentioned that before, and we're going to see how it performs. I mean, we're not too interested in actually the details of the performance. We're more interested in how the parameters will affect the different results. We can see that the probability variable profit and loss was 25.64 on the top rated, although blindly backing the top two rated, or the top rated, made a loss on both variable return and flat rate return as well. Let's make a change to some of these parameters. Let's increase this to 13. Run it again. Take a few seconds. And we can see that there's been a big change. It's actually decreased the probability profit or loss, and there's been changes here as well. So let's just pop that back to 7 and let's run a different algorithm. Let's try the one on the bottom, Minkowski. Now, the original intention with this software was to allow hyperparameter tuning through a hyperparameter button here, which would do a grid search of all these various parameters for different algorithms and then report back on which is the best. That may be a problem because I'm finding that when I compile this program in preparation for circulation, the one component that doesn't compile is the hyperparameter tuning via this button here. I think that's because of the fact that it uses multi-threading to implement hyperparameter tuning, and the compiler just falls over when it comes across that. So I will be introducing some hyperparameters for each algorithm that you can choose down in this section here, so that you can at least play around with the hyperparameters and tune them. We can see that the Minkowski algorithm performed very similar to the Euclidean. Let's just try one more. Manhattan. See how that performs. And again, that was similar with some slight changes here. Okay, hyperparameters, that's a brief introduction to them via the k-nearest neighbor algorithm. Different models have different hyperparameters. These are just specific to k-nearest neighbor, and they'll be available in the different algorithms that you can choose when you select the model back in the original menu here, original screen. Okay, hopefully this software is going to be available shortly, so if you're interested, check out the links below. And thanks for watching. Hope you enjoyed. If you've got any comments or suggestions, please put them in the comments section below. Thank you.